Hello and welcome to R&D Mathematics. Today we are going to talk about symmetry. Now in our last few videos we talked about graphs, how to plot graphs, things like that. For example, y equals x squared, it looks like this. See, there is a symmetry, right? And basically a relationship between y and x. It can be like this, it can be like that, or it can be like this. See this heart shape, there is a symmetry. In these two cases no symmetry, here there is a symmetry. So we are going to investigate a little bit more into this symmetry. Now an equation like y equal x squared plus 7 or x equal y squared minus 8, whatever, these are equations, and there is a difference between equation and a function, and we'll talk about that in detail when we are when we are learning functions. But for the time being, now basically we are going to talk about symmetries. Now there are three kinds of symmetry. In order to make this easier, let me put this in a table. Let me give you the theory first. Sometimes when I teach, I give you some examples first and give you theory later, but in this case I would rather give you the theory first. So let's say type of symmetry. An example or two of a graph. Algebraic test. Now it's, sometimes, not sometimes, in many cases you cannot draw these and check the symmetry. So that is exactly the place where we use algebra. So first symmetry, symmetric with respect to x-axis. Symmetric with respect to, let me put WRT, x-axis, right? And you can guess what the next symmetry is. Let me put symmetric, SIM, symmetric with respect to y-axis. And the third one I'll wait. Let's first talk about these two. Now if I draw my y-axis and x-axis like this, and symmetric with respect to x, so your x-axis, this guy now behaving like a mirror. So we are talking about a graph like this, right? Or it can be basically any shape. You know what, let me show you some graphs over here. It can be something like this. See, that part is mirror imaged your x-axis. So basically so many graphs, like if you put a man, a sleeping man like this, it's symmetric with respect to x-axis, right? Now let me erase those things. So the idea is this. So it's symmetric with respect to x-axis. If you look at this point, that point has coordinates, some x coordinate. In this case it's a negative number, a comma 0. But most importantly, let me erase that. Most importantly, look at these two coordinates. Your y-intercepts. Y-intercepts, there is something we need to understand. If you think this, see this height and this height, they are the same. Because of that, for example, let's say that's 3. Because if that is 3, this point, coordinate of this point is going to be 0, 3. And this point is going to be 0, negative 3, right? So in general, 0 comma b for some b, 0 comma negative b. That always happens. Now for the algebraic test, now this is the part that you need to actually remember. Replace y with negative y. And see what happens. So let me put it in this way, replacing, you know what, let me listen. Replacing y with negative y leaves the equation unchanged. Leaves the equation unchanged, right? The idea is clear because whatever this y height, you must have the negative y height of that one, right? That is the idea. But when we see more examples, you will understand. Now let's complete this chart. Let's complete this table. Next one, symmetric with respect to y-axis. So remember, for symmetry with respect to x, you replace y. So the other way around. So now with respect to y-axis, for an example, it's a graph like this. See, it can be something like this. Now the idea, this point, if I take this point, let's say a comma b, this point is going to be, well, if this point is negative a comma b, this point is going to be positive a comma b, right? Or it's easy to go with the intercept and understand. You have the same distance from the y-axis this time. See, in earlier case, you have the same distance from the x-axis, all those points. Now in this case, you have the same distance from the y-axis. Again, you don't have to remember these a's and b's, you don't have to remember these cases, but what you need to remember is this. So now, replacing x with negative x leaves the equation unchanged. So remember this. Now there is one more symmetry. Well, you don't have any more axes, x and y we all discussed, but there is one nice symmetry. And that symmetry is symmetric with respect to origin. Now, for example, a famous example, sin x curve, it goes like this. See, this one is symmetric with respect to origin. So here, replacing x with negative x and y with negative y, so both leaves the equation unchanged. The reason is explainable using this graph. For example, if this point is a comma b, this case, this point is going to be negative a comma negative b. See, in the previous two cases, here 0 comma b and 0 comma negative b. So 0 remains and the other one changed. Here, say negative a and a, b was fixed. Or even here, if I take this point a comma b, this point is going to be exactly a comma negative b, right? because this length is the same for both of those points, and the height is same, but as positives and negatives it's changing over here, and here the other way around. But here both of the, I mean here with respect to y-axis, here negative a comma b, here a comma b, only one coordinate is changing positive and negative. But in the last case, this case, both of them are changing. Here this length is a as a length, this is also a, but as a coordinates that is negative a, and this length is b, this length also b, but as a coordinate is negative. That's why you change, that's why you replace both of them. So that is the theory part, that is what's going on. But when we actually solve problem, what you really need is this part, this column right here in this table. Now let's see some examples. So let's take y equals x squared. Now in order to check the symmetry, so let's replace y by negative y. So what you just need to do to get your equation, instead of y, write down negative y. Are these two equations the same? Nope. Right? They are not the same. When I solve for y, it's going to be negative x squared. So it is not symmetric. Not symmetric with respect to what? X-axis. Let me show you. Let me go back and show you. If you replace by y and if the equation is the same, it's symmetric with respect to x. And if you replace x by negative x and if the equation is the same, it's symmetric with respect to y. So the other way around. And for origin, both of them. Now let's replace x by negative x in our equation. So you take this equation, y equals, instead of x you put negative x, please put parentheses because you are replacing x by negative x. So negative x, everything square is x squared. Now they are the same. So yes, symmetric with respect to y-axis. And if you replace both of them, so negative y, so both, replacing both negative y and negative x. So no, that's not the same equation. And this is an easy example. You already know the graph of this. Graph of this is this. See, it's only symmetric with respect to this y-axis. That's what we got, right? Now let's see another example. Y equals x cubed. Now we learned the shape of this graph. Can you guys remember? Well, it looked like this. Now let's apply our symmetry test. Replace y by negative y. So instead of y, I write negative y, x cubed. So they are not the same. So nope, it is not symmetric with respect to what? X-axis. And now let's replace x by negative x. So y equals negative x, please remember the parentheses, negative x cubed, negative into negative, again negative x cubed. So y equals negative x cubed, again no. So not symmetric with respect to y-axis. And that's clear, right? See, this part and this part are not the mirror image under either x-axis or y-axis. It's different. But if we replace both, so instead of y I put negative y, instead of x I put negative x. Now let's see. Negative y equals negative into negative x cubed, and when I divide by negative I get y equal x cubed, and they are the same. So this time it's symmetric with respect to origin. And it makes sense. Look at this, that according to our picture, if my origin behaves like a mirror, this part is the mirror image of this part over here, right? Okay. And let's see another example. One more example. So y squared equal x. So let's replace y by negative y. I get negative. I remember parentheses. Whenever you have to square and whenever you this replacing, please use parentheses. So y squared equal x. See, they are the same. So this guy is symmetric with respect to what? X-axis. Why? Because I replace y. And let's replace and see. Replace x by negative x. Y squared equal negative x. They are not the same. So nope, not symmetric with respect to y-axis. So when I replace both, see, this replacing both story is not equivalent to replacing. What I'm trying to say here is, at this point, you cannot conclude it's better to do it again, because replacing both means replacing both at the same time. What you earlier did was you replaced y by negative y, not x in the first case here. And in the second case, you replaced x by negative x, but you kept y as it is. But when you do both, you are doing both at the same time. So y squared negative x, again no. So not symmetric with respect to origin. So this shape y squared equal x, actually if you draw it, you will see, if you point, plot and draw it, you will see this shape, and it's symmetric with respect to x-axis, and that's what we got, and it's clear. Now you may be thinking, are there any shapes that are symmetric with respect to both x and y? Well, yes, there are. Are there any shape that is symmetric? Let's see, with respect to both x and y. How about this shape? Is it symmetric with respect to both? No, right? When you take the mirror image, that's not. Can you think about shapes that are symmetric with respect to both x and y axis? So let me pose these two questions. Second, with symmetric with respect to x axis, y axis, and origin as well. Now this is a little tricky. So my question is basically, can you think of a shape? See, we already saw shapes that is symmetric only with respect to this, only with respect to this, and only with respect to this. So my question, can you think of a shape or shapes that has these first two symmetry, and a shape or shapes that has all three symmetries? That's a nice IQ question, thinking kind of question. And before I end this video, there is one more thing. Most of the shapes that you see will not have a symmetry. Keep that in mind, right? It's not the case that you have to have a symmetry. Something like this, no, and not any symmetry, not any symmetry. So most of the things, it may be the case that all those symmetry tests will fail. In that case, there is no symmetry. And keep thinking about that question, and that's enough for this video, and see you later. Thank you.